The next section we are going to see is 1.4, solving system of linear equations using the inverse matrix. So in basic mathematics we have seen this solving the linear equation, that is for solving for x, solving for y, we get the value of x and y. The same problem we are going to do it, we are going to solve it by using the inverse matrix method. Solving system of equations. Theorem. If A is a non-singular matrix, n cross n matrix, determinant A is not equal to 0, then the solution of the linear system Ax is equal to B is x is equal to A inverse multiply B, where x and B are n cross 1 matrices. In this theorem, they are giving us the idea how to solve the system of equations. Now, if A is a given non-singular square matrix, non-singular means the determinant should not be 0. And it is a square matrix, n cross n. Okay, so then the solution, the answer for that linear system can be got by using the formula x is equal to A inverse multiply B. So now we know A is a matrix, B is a matrix, and X is also a matrix. So X is the unknown, X is the unknown matrix. From A we can find A inverse, and we know B, we multiply A inverse and B, we get the value of X. So this is the formula we need to remember. X is equal to A inverse multiply B. Now let us look at the equation. A1x plus B1y is equal to C1. A2x plus B2y is equal to C2. So this is a linear equation because x and y have the power 1. So we say linear. And A1, B1, C1, A2, B2, C2 are just numbers. To see how we can rewrite a system of equation as matrices. So now we are going to see how we can write it as a matrix. Now I am going to write in the form of Ax is equal to B. So here A is the coefficient matrix, X is the variable matrix, B is the constant matrix. The coefficient matrix A is nothing but the number before X, number before Y, number before X and number before Y. We see A1, A2 before X, B1, B2 before Y. So that we write it as two columns and it is a square matrix. Next, the two variables here are X and Y. We need the value of X and Y. So this is a variable matrix. It is a 2 cross 1 matrix. Next, what is in the right side, that is C1 and C2. So that I write it as one column. It is a 2 cross 1 matrix. So this is a constant matrix. So now I know A is nothing but A1, B1, A2, B2. X is a matrix XY and B is a matrix C1, C2. Use the inverse matrix method to solve the system of linear equation. So this will be the question, and they give you two equations, 3x plus 4y is equal to 5 and 5x plus 6y is equal to 7. So now I want to solve this and I have to find the value of x and y by using the inverse matrix method. So now let us write the answer. Solution. The system of linear equation can be written as follows. So now we have to write this linear equation in the matrix form. So the matrix form is, First, we have to write the coefficient matrix. The coefficient matrix is before x we have 3 and 5. We write it as first column. Before y we have plus 4 and we have plus 6. So we have to take 4 and 6. So now it is a 2 cross 2 matrix. Next one is the variable matrix. So we have two variables x and y. So that is equal to what is in the right side, it is 5 and 7. So we get A is a 2 cross 2 matrix, X is a 2 cross 1 matrix, and B is the constant matrix. It's also 2 cross 1 matrix. So now let us find the A inverse. We have to find the A inverse. So for that we have to find the determinant of A. Determinant of A is 3, 4, 5, 6. That is equal to 18 minus 20, that is equal to minus 2. So minus 2 is the value of the determinant. So A inverse is equal to 1 divided by minus 2, and we have to put the matrix bracket, and we have to interchange the numbers in the forward arrow, that is 6 and 3, and in the backward arrow we have to change, backward diagonal we have to change the sign. So minus 4 minus 5. So now we get 1 by minus 2 into 6 minus 4 minus 5 3. Now we can multiply this 1 by minus 2 inside the bracket. So we get minus 6 by 2. So minus 4 into 1 by minus 2 is 4 by 2. Minus 5 into 1 by minus 2 is plus 5 by 2. So 1 by minus 2 into 3 is minus 3 by 2. So if you simplify this, it will become minus 3 by 2. It is 2, 5 by 2, minus 3 by 2. So this is A inverse. So minus 3, 2, 5 by 2, minus 3 by 2. So now we have to find the solution for the linear equation. I know A inverse now, I know B. You know the formula for finding the solution is x is equal to A inverse multiply B. So x is equal to, x is a matrix, that is xy, small x, small y, it is a bracket, within bracket. And next A inverse is minus 3, 2, 5 by 2, minus 3 by 2. And B is the matrix 5, 7. So now xy is equal to, so now we have to use the matrix multiplication. A inverse is a 2 cross 2 matrix, and C is 2 cross 1 matrix. So the final answer will be 2 cross 1. So we can multiply. So we multiply first row, first column. So minus 15 plus 14. The next one is 25 by 2 minus 21 by 2. So that will be equal to minus 15 plus 14 is minus 1. 25 by 25 minus 21 divided by 2. That is equal to minus 1, 4 by 2. So that is equal to minus 1, 2. So that is x comma. So now the value of x is equal to minus 1, the value of y is equal to 2. So now we got the value of x and y. So this is how we solve the system of linear equations by using the inverse matrix method.